Hey guys, today we'll be presenting the traffic control compliance written by Damian Austin and Dede. This is our agenda with the 5 following steps. Introduction. When did we collect the data? It was on November 10, 2022 at 2:30 p.m. on a Thursday, where we choose the robust way of pulling technical land. We know that the traffic control compliance allow engineer to tailor the transportation system to suit the traveling public need. So we collected this data to provide information needed to examine the effectiveness of traffic control and regulation. Effort of statement. Damian worked on the data discussion and conclusion. Austin worked on the introduction and the result, and Dede worked on the introduction and objective.
Here's an image of our intersection with Group 1, our data going northbound, and Group 2's data having been collected going southbound.
These two tables are a summary of our field data for Group 1, who did northbound, and Group 2, who did southbound. The table shows us the total number of vehicles observed during a 1 hour period for frequency and the confidence limits at 95%. Our confidence level for both groups ranges from 0.03 to 0.096%. This next table shows us the comparison between north and southbound drivers who are obeying the right turn stop sign. As we can see, for northbound, our complete stop plus our rolling stop is 38, while southbound is 21. And for our no stop plus our stopped by traffic total, for northbound is 62, southbound is 79. They both come up to a total of 100 vehicles.
Using the confidence intervals from before, we can establish a range of estimates concerning the percentage of cars that will take a certain action. For example, for the complete stop action, which means there is no movement and they come to a complete stop at the stop bar, the northbound movement is 95% confident that 14 to 30% of all vehicles coming through will come to a complete stop. Group 2, on the other hand, who had the southbound movement, can only expect 0 to 8% of all vehicles moving through to come to a complete stop. One of the more drastic differences was the no stop. The northbound movement group is 95% confident that only 0 to 6% will have no stop, while the southbound group is 95% confident that 28 to 46% of cars will not stop. Here's a z-value calculation to see how significant the difference is between the data collected and the frequency of actions taken by each vehicle at their respective movements. These have to do with compliance. So for yes, these are vehicles that did come to a stop, and no, these are vehicles that did not. The z-values were 2.68 and negative 2.68. For a 95% confidence interval, these are both off from the 1.96, which means the difference is statistically different between the two approaches. Here's a source of error based on where we took our data. Sometimes if a car, such as the green car, would pull up too much, we wouldn't be able to see if the blue car stopped or rolled through. We would just see the blue car pop out from behind the green car. And so some of the data will be skewed as we had to assume what the vehicle did. In conclusion, based on our range of estimates, we were able to conclude that more vehicles come to a stop on the northbound approach, more vehicles come to a rolling stop on the northbound approach, more vehicles come to no stop on the southbound approach, and more vehicles are stopped by traffic on the southbound approach. We can come to these conclusions because of the difference in the estimates. For example, on Group 2 for the complete stop, their maximum expected percentage to come to a complete stop is 8%. While the minimum for Group 1 is 14%. So there will be a higher percentage of complete stops on the northbound approach. And so we can come to a decisive conclusion that more vehicles will come to a stop on the northbound approach. The same holds true for the rest of the actions listed. And that concludes our presentation.